When a server trusts the user input too much, attackers don't need passwords. They just need the server to talk for them. Today, that trust leads to a stolen cloud identity. Welcome back to 5 Minutes Cloud. This is Easy to Attack series, and today we are going to explore about how SSRF vulnerabilities can lead to unauthorized access of AWS cloud resources. Now, before we jump to the tutorial, we need to ensure the understanding of 4 things. First, SSRF. Second, IMDS. Third, IAM. And the fourth is STS, which is Simple Token Services. Now, what is this SSRF? So SSRF stands for Server-Side Request Forgery. Imagine you visited a hotel and there is a hotel front desk. There is a staff-only room where you cannot visit. But if you need something, you can ask the staffs to bring it for you. That's exactly how SSRF works. Attackers do not access the internal servers directly. Instead, the server accesses on their behalf. Here, the server is trusted and not the attacker. Now, what is IMDS? IMDS stands for Instance Metadata Service. It is the endpoint which has information about the instance, which includes the information related to compute, storage, networks, and security. The Instance Metadata Service has 2 versions, version 1 and version 2. For our today's tutorial, only the version 1 is in the scope because it is not going to validate the request method and the request headers. So that is why it is easily exploitable using the SSRF vulnerability. Now the third one is IAM roles. So IAM roles are basically used to provide non-human identities so that they can access the AWS infrastructure. Now it is not only restricted for the AWS EC2 machines, but you can attach the IAM roles to numerous of AWS services. The fourth and last thing is Simple Token Services. Now the Simple Token Services are pretty simple to understand. It provides you the temporary credentials against the IAM roles or any other IAM entity which you are going to provide. Now it's time to jump to the demo. Let's go back to my screen and see how we are going to solve today's challenge. This content is strictly for educational and awareness purposes. All attacks demonstrated are performed on self-created lab environments. Unauthorized testing or exploitation of systems without permission is illegal and unethical. The creator is not responsible for misuse of the information shared. Alright, so now on my screen, on the left hand side you will be able to see a tutorial, and on the right hand side our lab. Now in this tutorial you will be able to see like how we are going to exploit these things, and we will take help of this tutorial to solve this lab. Now you can also access this tutorial on our website, that is 5minutescloud.com. You'll also get the direct link of this tutorial in the description of this video. Here you can see that abusing SSRF vulnerability to access EC2 instance metadata version 1 and still IAM role credentials. Now before jumping directly to the tutorial, let's understand the entire attack path. Now here we have an EC2 instance which can be accessible publicly over the internet. On this EC2 instance, there is a web application hosted which is having an SSRF bug. You can also see that there is an IMDS v1 enabled, and then there is an IAM role attached. Now the attacker will access the web application hosted on this EC2 instance, exploit the SSRF bug, access the IMDS v1 endpoint, enumerate the IAM role. After having the IAM role, the attacker will try to get the temporary credentials from the STS, and using that temporary credentials, the attacker will now be able to access the services which this particular IAM role has access to. Now it's time to exploit this and solve this particular lab. Now here you will see the entire walkthrough. If you want, you can go through this introduction. Now this lab is private, so it is only accessible to me on my proxy network. To access this lab, I'll go to this URL, and since the IMDS instance metadata endpoint can be accessible on this particular IP, which is 169.254.169.254. It is different for different cloud platforms. In order to check whether this particular application is vulnerable to SSRF, we will simply provide localhost, and if this localhost is resolvable from the server side, we will ensure that this is vulnerable to SSRF. Since we know that this is an intentionally vulnerable lab, so it is responding with the HTML version of this particular website which is hosted locally. Now how we can enumerate the IAM role from this instance metadata endpoint? So we will just copy it and then we will paste it over here, which is going to return the IAM role name. Now understand, Instance Metadata Service can only be accessible via this particular endpoint, and there is also metadata internal domain for it, which is different for different cloud service providers. Now this Instance Metadata Service has all the information related to this particular instance. You can enumerate everything related to this instance, whether it is the private IP, public IP, security group, subnet, VPC, everything you will be able to enumerate. But for us, the most interesting part is getting the IAM role, because against that IAM role, we will be able to enumerate the credentials. Alright, now we have this IAM role. So we are just going to pass this IAM role name after this particular security credentials path. So I'll copy it again. I'll go over here. I'll paste it. And then we are having the entire access key ID, secret key ID, and session token. Now, once we have the access key ID, secret key ID, and session token, we can basically configure it using this AWS CLI command. Now here is my terminal. I'll just paste the command to configure the AWS credentials on my terminal. I'll copy this command and I'll paste it over here. It will ask me for the access key ID. For you, it might not show you this particular pre-configured access key ID because in my terminal, I have configured it earlier. So that is why it is showing like this. I'll just copy this access key ID. I'll paste it over here. I'll do the same for secret key ID. I'll paste it over here. The region name and the output format, I'll keep it as it is. Next command is to configure the session token. I'll copy this. I'll paste it over here. Oh, my bad. I just need to add the session token over here as well. I'll copy the session token all the way till this part. I'll paste it over here. Press enter. I'll clear off my screen. Now, once we have configured the credentials, before jumping to other part, we have the hacker's advice. Let's go through it. Now it says that if you configure these credentials on your local machine, Amazon Guard Duty might flag it as a potential threat. Now here, Amazon Guard Duty is a threat detection tool which might flag it as a potential threat because these credentials belongs to EC2 instance role and using them outside the instance is considered suspicious. So what's the hack? You can spin up a temporary EC2 instance on your AWS environment and configure these credentials there. That way you are staying within the intended boundary and avoiding the Guard Duty alerts. But that's not the solution. Guard Duty strikes again that unauthorized access IAM user instance credentials exfiltrations inside AWS. This particular warning will be triggered even inside AWS. So we need to find the other way. But the saddest part is there is no other way until unless if you are not using the same account. Now it's time to check whether the credentials that we have configured is working or not. In order to check that, we have this command AWS STS get caller identity and then we are going to provide our profile. So it is going to check that whatever the credentials that we have configured is belonging to any particular IAM entity or not. So let's copy this, paste it. Now it will return that this particular credentials belongs to an IAM instance role and it is basically assumed, and here is the role and here is the instance ID. It means that the credentials that we have configured is actually valid and working. Now the story changes from here. Once you have the credentials, now you can use these credentials to exfiltrate whatever you want. You can try to brute force the AWS APIs using multiple tools so that you can get the information from there whether you have access to certain services or not. Now the real challenge is how you're gonna fix it. This is the machine which we have just exploited. Now you can see this inside my AWS environment. I'll go to the Actions tab, go to the Instance Settings. All the way down, you will find the Modify Instance Metadata options. I'll click on it. I'll ensure that IMDS v2 is set up if it is enabled. I'll click on Save. Now if I'll try to exploit it, it will not work. Let's see. Now I'll use the same URL to enter over here and to see whether it is going to fetch or not. Now you are seeing that failed to fetch the URL. Now the reason is straightforward. The instance metadata version 2 requires you to fetch a token first using a put request. You can use this put request along with a header. After that you will get this token and that token you will have to provide in each and every request along with a header in order to access the instance metadata endpoint. And this is how you will be able to access it. But this particular request method and the headers is something that you cannot control inside the SSRF. That is why upgrading to IMDS v2 restricts you from accessing the instance metadata endpoint and it will act as a safeguard against SSRF-based attacks. Thank you for watching this video. Do share and subscribe this channel.